today I'm going to present the final presentation for the subject CS767, which is Advanced Machine Learning and Neural Networks. And my topic for today's presentation is Nifty and SPY volatility anomaly, anomaly detection using deep learning. So basically, what is Nifty and SPY? That I want to speak about that first. So Nifty and SPY are the financial data for the stock markets of US and India and US respectively. So let's talk about my problem statement. So traditional statistical methods for anomaly detection often fail to capture the complex and nonlinear patterns present in the financial data. So the objective of this project was to evaluate the use of neural networks in detecting anomalies, particularly in the volatility data of Nifty index and the SPY ETF. So we want to focus on the matrices such as the prediction, accuracy, and sensitivity of anomalies, addressing the limitations of conventional methods, and so aiming for a robust and a reliable detection mechanism, basically. So I'm gonna talk about the data set now. So as I said, the model that I've trained my the model I've trained is on the data set for Nifty and the SPY indexes. And I've basically gathered the financial data from these are reliable resources which are Yahoo Finance and some APIs that I found online. And I took 5 years of the past 5 years of the data to process my model. And there were several columns, but majorly it was similar for both the data sets, and it was date, closure, close, volume, open, high, low, volatility, etc. So I want to talk about the implementation, which is the major part, and I want to talk about like the step by step how my project is working. So I want to talk about the imports first. So basically, my model accurately identifies anomalies visualized alongside predicted and the actual volatility. And the model was implemented using PyTorch, is widely used deep learning library that allows flexibility, efficient training of neural networks. So libraries such as Panda, NumPy, uh, were also used. Torch, Matplotlib, and others are imported. So these libraries help basically with the data processing, deep learning, distance-based calculations, and visualizations. So they all read the data sets for SPY and Nifty, which were loaded in the CSV file, and then first few rows of each data set are printed to understand the structure that was visual in the photo that was shown in the previous slide. So then the SPY data set with the date column is converted into the date time format, and the close is cleaned by removing dollar signs and converting it into basically like float. And then it's renamed it to close. And it's also formatted correctly. Like basically, all I'm explaining is data cleaning and all of that. Then the data is aligned. So both the data sets are merged based on the date column to ensure the date alignment of for more accurate, basically for both SPY and Nifty. And then the returns calculation. So daily returns are calculated as so percentage change in the close for both the data sets. So uh, and now the volatility calculation, a 14 days rolling standard deviation is calculated. So daily returns to estimate the volatility. And the drop NAN, so rows with NAN values caused by the rolling calculations are dropped. Basically, I try to omit that. And with the data preparation, so for the new data set and the merged data contains both the SPY and the Nifty volatility data. And so like a separate array is normalized using the standard scaler. And then the data set for time series prediction is used. Where the time series dataset class, the custom PyTorch data set prepares the data for time series modeling, and it takes in the sequence length and prepares sequences of data to be used. So basically, the data set is divided into batches, and the loader objects are created for both SPY and they will facilitate the training. Uh, yeah, basically that. So here I mentioned some step-by-step things that I just said. Data collection, then there's data cleaning, normalization. The data was, as I said, as I just mentioned, the data was normalized to bring all the volatility values within a standard range, and then to ensure faster neural network convergence. And the train and test split, the preprocessed data was split into training and data set, 80% and 20%, and to evaluate model performance on unseen data. Here is my train and test split. Is evident with 20, taken 20 epochs, with the losses calculated at every step. So now I want to talk more about the tools that I use. So PyTorch is fully featured framework for building deep learning models, as I said, so it is a type of machine learning that's commonly used in applications like image recognition or language processing. And it's a relativity used in it's the most easy machine learning developers to learn and use. And so now talking about NumPy and Pandas, they're used for data pre-processing and manipulation. The use case is very essential over here because they're the foundation of any numeral competition in Python, and they're building blocks for other libraries like Pandas. And they focus on data manipulation and analysis and frameworks that was really used here. And so working with the tabular data and data cleaning was essential. So hence, NumPy and Pandas came into the play. And now talking about Matplotlib and Seaborn. So these are the two most popular Python libraries used for data visualization. Here's a breakdown of the key differences and when to use each. So, basically, the lower level library uses like often for like fine-grained control, such as axes, text labels, and the colors are required to use Matplotlib. Seaborn are usually used for high-level libraries. Now talk about Scikit-learn is an open source built on NumPy and SkyPy. It is used for many big This is used in many big organizations, and it's easy to develop it, such as JP Morgan, Evernote, and yeah, basically they use for scaling and splitting the data into test and training data sets. Now, I'm going to talk about the statistics. So, as you all can see, so there's a term called R square. I want to first explain what R square is. So it is a statistical measure that represents the portion of variance for dependent variable explained by independent variable for a model. So a higher R square value means that the prediction fit the actual data more closely. Here, as seen, the R square value that we've evaluated is closer to 1 for both SPY and Nifty, which is 0.9443 and 0.9611. Hence, indicates a strong predictive accuracy. Uh, Now, talking about the DTW distance. So the DTW basically is dynamic time wrapping. So the dynamic time wrapping is a technique for measuring similarity between two time series, even if they are perfectly aligned. Like here, I just shared the cleaning and everything, they were perfectly aligned later. Even if they are not perfectly aligned, it is particularly useful when the time series data is present. So the DTF function here calculates the distance between the two volatilities, and which is 0.0544. So a low DTF indicates that the two volatility time series are very similar, and even accounting for similar potential shifts or timing differences, as we can see over here. And now talking about the correlation. So correlation is a linear relationship between two variables, as we all know, and the value ranges between -1 to 1, basically perfect negative correlation or perfect positive correlation, and the value closer to 0 indicates no correlation at all. And so here we can see that the correlation is extracted as 0.8217. So it is a strong correlation with 82.17% between the SPY and Nifty. This indicates that the SPY volatility increases, the Nifty volatility tends to increase as well. Now moving on to the next slide. So talking about the results. So the deep learning model effectively predicted volatility and identified anomalies in both the Nifty and SPY datasets. So the visualizations that I'm going to show you later confirm that the accuracy and the reliability of the approach offered financial analysts a robust tool to monitor and understand unusual volatility spikes. So these results highlight the potential of AI-driven techniques to for improving decision making, risk management, and market analysis in the real-world financial scenarios. So here I'm going to talk about the actual volatility graphs that I've incorporated. So here so basically it represents the true value of the data sets for over 30 days. And the actual volatility has sharp peaks and valleys with one notable spike at day 25, which is evident. Uh, Whereas the model's prediction for the SPY volatility is based on previous data. The prediction closely follows the actual trend but are slightly smoother and less extreme. So there are around like at the day 25, there's a high spike in actual volatility while the model predicts an increase. It underestimates the peak. And I have the reasoning for the peak because it was COVID and the uh, the model actually couldn't read that there's some anomalies that have to be incorporated with. And hence the previously calculated R square value of 0.9443 also confirms the strong correlation. Same is the case with the Nifty dataset. But unlike the SPY, there is no peak or there's less discrepancy because the Indian market actually did well while going through the pandemic. Now, now talking about the anomaly detection. So, so this represents the true volatility values observed for the SPY over time period and of 30 days. So it represents the volatility of the model. The predicted volatility generally tracks the actual value closely, showing a similar trend. Uh, Points where the differences between the actual and the predicted value exceeds the threshold. This indicates that the model prediction failed accurately to capture the extreme volatility at spike. That it happens only once on the day 30, as seen over here, with the blue and the orange taking a difference. Now moving on to the Nifty volatility anomaly detection. So here the predicted volatility aligns well with the actual volatility for most points, capturing the overall trends and the short-term variations. So this model performs well in capturing the general volatility patterns, but misses extreme anomalies caused by sudden market events. And the detected anomaly can be used to investigate further for unexpected market behaviors. So to improve performances, this model could be trained for more extreme events or volatility spikes. Uh, but it kind of did well for Nifty volatility anomaly. So I want to talk more about future work that could be incorporated for this model or in general for this idea. So additional indices. So I want to analyze more data sets for the model, which could be Dow Jones, Nasdaq, or and FTSE for a broader market understanding. Advanced techniques. I want to implement autoencoders, LSTMs, and isolation forest so that a better anomaly detection could be incorporated. So I also want to incorporate a better noise handling where the robust regularization and ensemble methods would stabilize my model. And the real-time detection is extremely important to extend the model like I said, there's a pandemic and it showed anomaly. So to incorporate real time, we would even decrease the percentage of error. Explainable AI integrate interpretability tools like SHAP or Line for a transparent anomaly explanations.